The focus of this module is to use order of operations to solve different mathematical problems. Let me give you an example of what I'm talking about. Let's say two students are given the following problem to solve. 6 plus 3 times 2 equals. One student says, well, 6 plus 3 times 2 means I'm going to add 6 plus 3 and get 9, and then 9 times 2 gives me an answer of 18. Another student looks at 6 plus 3 times 2, and instead of doing it that way, that student says, well, I like to multiply first, so I'm going to multiply 3 times 2 and get 6, and I get 6 plus 6, so I say that the answer is 12. Which one of these two answers, 18 or 12, is the correct answer? This is what we will be exploring in this module. Before continuing with order of operations, I want to just review a couple of rules of mathematics that I am sure that you have heard, but may have forgotten the terminology. The first rule is the commutative property of addition. All the commutative property of addition says is that if you are adding together two numbers, for instance 5 plus 8, it doesn't matter which number comes first. In other words, 5 plus 8 is exactly the same thing as 8 plus 5. Remember, this is with two numbers, and it's called the commutative property. Another rule is the commutative property of multiplication. As the name implies, if you have two numbers that you are multiplying, for instance 6 times 7, 6 times 7 is exactly the same thing as 7 times 6. So there are rules for the commutative property of addition and for the commutative property of multiplication. Is there a rule, the commutative property of subtraction? In other words, is 8 minus 5 equal to 5 minus 8? Those two are not equal to each other, so there is not a commutative property of subtraction. For the same reason, 12 divided by 3 does not equal 3 divided by 12. So there is also not a commutative property of division. There are just commutative properties of addition and multiplication. You probably also remember hearing a rule known as the associative property. The associative property is very similar to the commutative property, except instead of adding or multiplying two numbers, we are adding or subtracting three numbers. For instance, if you are given the problem 3 plus 4 plus 5, one way you can certainly do that problem is you can add together the 3 and the 4 first and get 7. So 7 plus 5 gives you 12. However, if you wanted to, you could, with 3 plus 4 plus 5, you could add together the 4 plus 5 first, then you would get 3 plus 9, and you would also get 12 for an answer. Truthfully, you could, if you wanted to, even change the numbers around. Instead of 3 plus 4 plus 5, I could do 3 plus 5 plus 4. I could get 8, and 8 plus 4 also gives us 12. I know this is common sense, but it is a rule that is found in mathematics known as the associative property, this one being the associative property of addition, and I will be using these terms here throughout this course and into the next course, so I wanted to start off by reviewing these. Of course, this is the associative property of addition. The associative property of multiplication works exactly the same way, and just like for the commutative property, there is not an associative property of subtraction, nor is there an associative property of division. One other idea I want to explore before we get back to order of operations is the idea of exponents and square roots. Once again, you probably have heard these terms, but I want to review the concepts briefly because they are so important to what we are going to be doing with order of operations. So, what is an exponent? An exponent is used to show repeated multiplication of a number known as the base. You have probably seen something that looks like this: a 3 with perhaps a smaller 4 just above the 3 and to its right. In 3 to the 4th power is one way to say this. This number right here, the 3, is known as the base, and the 4 is known as the exponent. 3 to the 4th power is one way to say this, and 3 to the 4th power means that I need to take the number 3 and I need to multiply it by itself 4 times because it's to an exponent of 4. If I were to go through and solve this now, 3 times 3 is 9, times another 3 is 27, times another 3 is 81. So 3 to the 4th power is equal to 81. There are some special terms that are used when using exponents. For instance, if we have 5 raised to the 2nd power, one way to say that is 5 to the 2nd power, and certainly it means 5 times 5, because we need 2 5s. But you can also say for this 5 squared, and you have probably heard that before. Anytime you have something to the 2nd power, instead of saying to the 2nd power, we oftentimes use the word squared. At the same time, if you have 5 to the 3rd power, 5 to the 3rd power means 5 times 5 times 5, which is equal to 125, because 5 times 5 is 25, times another 5 is that 125. But any time at all that something is to the 3rd power, instead of saying to the 3rd power, we oftentimes use the word cubed. So 5 cubed is the same thing as 5 times 5 times 5, which is equal to 125. So I would like to give you 4 problems to do on your own. And what I would like you to do is to write down these 4 problems, then pause the video, do them on your own, and then start the video up again and check your answers. So the 4 problems are 7 to the 2nd power, 1 to the 5th power, 4 cubed, or 4 to the 3rd power, and 6 to the 1st power. So please do those and then start this back up again when you are ready. Okay, hopefully you've been able to go through and do these 4 problems. 7 squared means 7 times 7, which is equal to 49. 1 to the 5th power means I need to take 1 and I need to multiply it by itself 5 times. So I still get 1 for an answer. 4 to the 3rd power, or 4 cubed, means 4 times 4 times 4. And 4 times 4 is equal to 16, and then 16 times another 4 gives me 64. And 6 to the 1st power just means that I have 6. I'm not going to multiply by another 6, so that final answer is 6. There are a couple of special cases of exponents that you do need to become familiar with for this course. For instance, what is 5 to the 0 power? Many people take a look at this and say that 5 to the 0 power is equal to 0 because you don't have anything. But that is not true. 5 to the 0 power is equal to 1. And let me show you why. You know, we've already talked about it, that 5 to the 3rd power means 5 times 5 times 5, which is equal to 125. We know 5 to the 2nd power is 5 times 5, which is equal to 25. We know that 5 to the 1st power is equal to 5. Notice that we have a pattern here. I have my exponents, and I keep on reducing my exponents by 1, 3, 2, 1. When I do that, 5 to the 3rd power, I got 125. 5 to the second power, I got 25. In other words, to get from 125 to 25, I really divided by 5, because I'm only multiplying by 2 5s in this case, rather than by the 3 5s in this case. The same thing holds true when I go from 25 to 5. 25 divided by 5 divided by the base gives me 5 for an answer. All math is a series of patterns. So if I continue with my pattern here, now I'm going to go 5 to the 0 power. I'm going to reduce the exponent by 1 again. The same pattern has to be true. I have to be able to go through, and I have to be able to divide the previous answer by 5. 5 divided by 5 will give me an answer of 1. So 5 to the 0 is equal to 1. A very important part of mathematics. It doesn't matter what the base is. I'm just going to call it b right now. If b is the base, anything to the 0 power is always going to be equal to 1 for that particular reason. And that is something that's very important, as I say, not only for this course, but for the next course if you are going to be taking the Math 102. So, what about having a negative exponent? Is that possible? For instance, 5 to the negative 2 power. There is an answer for 5 to the negative 2 power, and although we won't be exploring it a lot in this particular course, we will certainly in the next course, and there may be times in this course where we explore this idea just slightly. So let me continue with this. As we said before, we know that 5 to the third is equal to 125, 5 to the second is equal to 25, 5 to the first is equal to 5. Now we know 5 to the 0 is equal to 1, and that pattern just has to continue. So if I have 5 to the negative 1 power, I'm going to have to take this particular answer 1, and I'm going to have to divide it by 5. So 5 to the negative 1 is equal to 1/5. If I continue, 5 to the negative 2, 5 to the negative 2 means that I need to take the previous answer 1/5, and I need to divide that by 5. 1/5 divided by 5 is 1/25. So 5 to the negative 2 is equal to 1/25. Notice that it's the same thing as 5 squared. 5 squared is equal to 25. It's exactly the same number. It's just that the 25 goes to the denominator, and it's 1/25. If this idea of negative exponents is something that seems crazy to you, please don't worry about this particular part. You will not be tested on negative exponents in this module, and certainly when we do get to negative exponents again later on, we will go into it in much more depth. I just thought that I would take a few seconds and talk about it here because it is a question that does tend to come up a lot when we get to this particular point. The last idea to talk about before we get into order of operations is the idea of square roots. Square roots are the opposite of exponents. We know that 3 to the second power is equal to 9 because 3 times 3 is equal to 9. If 3 to the second power is equal to 9, then the square root of 9, and I could write it out like this, the square root of 9 is equal to 3. Because what I'm asking for with the square root of 9 is what number can I multiply by itself in order to get 9? The square root is written with a symbol, and this is the square root symbol. And you would normally see it written like this, the square root of 9. The square root of 9 is equal to 3, as I say, because 3 times 3 is equal to 9. So another example, what is the square root of 25? we were being asked what number can you multiply by itself in order to get 25? And that answer would be 5. The square root of 49 is equal to 7, because 7 times 7 would give me 49. The square root of 100 would be equal to 10, because 10 times 10 is 100. And the square root of 1 would be equal to 1, because 1 times 1 gives me that 1. Notice that all of these answers that I gave right now are perfect answers. In other words, these are perfect square roots. If I have something like the square root of 90, what number can I multiply by itself to get 90? There is an answer. It's just not a whole number answer, and instead would be a decimal. It would be something that we could use a calculator for to get the answer. In this particular module, we will not be doing anything with something like the square root of 90, but instead we will just be dealing with things that give us a perfect square root answer, similar to all these ones that I am circling. Before going on to the second video in this module, where I will talk about order of operations, I would like you to complete the quick check on this module, which can be found next. In it, you will find 5 quick problems that can be used to check your understanding. If you do well on the quick check, you are ready to watch the next video. If you have difficulty with it, you may want to review this video again, or certainly get in contact with me directly so we can talk about your questions.